welcome. The topic for this final lecture or presentation of the fall semester is Linux for Researchers. I'm Steve Lance here at the Center for Advanced Computing. And there's a lot of possibilities here for what we could cover in an overview of Linux, of course. It's supposed to, I think, be for people who are perhaps less familiar with what goes on at the command line in Linux and would like to know more. I'll be covering some tricks as well as standard commands and just give you a general flavor of how you work with Linux, which you're likely to encounter in research computing of one kind or another, and just get into some of the many things that are fascinating about Linux just this morning. Okay, so first we're going to talk about Linux, as an operating system and where it fits into things. So compared to your common PC type operating system, Windows, Mac OS, Linux is free and open source. In fact, according to Red Hat, it's the largest open source software project in the world. And that makes it a natural companion for open source software that is written by researchers and used by researchers. It is sort of something that's researchers took to it especially well, and things that are innovative have often come out of the Linux world. It's not, though, Linux is what we refer to often as this operating system that is its own thing, but there's a parallel to it, in fact, a predecessor to it called Unix. So Unix goes all the way back to the 60s, but it was proprietary. In fact, there were several proprietary versions. You could buy it. It had all the flavor of, say, Windows or any other proprietary operating system of the time, except this was mainframe days, right? So yeah, and the contribution of Linus Torvalds is the kernel then was written in such a way to and publicized so that anybody could contribute and write a Unix-like operating system. So Linus bestowed his own name on this project. That's how it got its name, Linux. But in a sense, it should be called maybe GNU/Linux. So there's a related project called the GNU project by Richard Stallman, and that was the idea that people should, in fact, give away the software for free and not pay for it as a product. And so the tools that were created through the GNU project figure heavily into the usability of Linux, because Linux, after all, is only the sort of inner workings of the main of the operating system. It's a sort of the micro thing, and all the things that you use in Linux are really GNU tools for the most part. So it's a powerful operating system. It has had so many additions and contributions over the years that it's gotten to be dominant in some areas. So it was, since Unix was the first operating system to include TCP/IP, which is a protocol that runs the internet essentially, Linux has taken over, and basically Linux today runs the internet. It runs all the top 500 supercomputers. It runs all the major stock exchanges. I mean, it's fascinating how much computing infrastructure depends on Linux. And yet, because it's a tight, small, or can be a tight, small operating system, you can embed it in thermostats and refrigerators. It's showing up in many places that you just don't think of as being Linux environments. And at this point, I'm going to just point out that we're taking questions today through chat, and as Ben posted there, you can just go ahead and we'll take moments to answer questions if you have them. Okay, so that's the sort of the cool stuff about Linux. Where does Linux have issues? So this fascinating aspect that it's free and open source means that nobody owns it exactly. So anybody can make a distribution of Linux that might have a little bit of a different tool set in various ways, or work slightly different, or support different file systems, whatever. How, if they're all free, how do these things, make money? So the distributions that are out there, which are nicknamed distros, they are backed by companies that earn their money by providing support. And the incentives are to have your distro work well as a Linux operating system, but it's really not quite the same as a rival distro. And therefore, you don't get total lock-in with your distro, but it will be a little painful or not uncomfortable to switch you to. So, and the thing that happens in Linux is forking. So anybody can fork an open source project and do a little something to it, and that's then some new project. So there's this, the forks that are the most prominent today would be the Debian fork and its derivatives, the most famous example being Ubuntu, the Red Hat family, which includes Red Hat Enterprise Linux as the product sort of version. Upstream of that would be Fedora. That is to say that Fedora sort of advertises the new set of features coming up in Red Hat Enterprise Linux. Downstream of it, that is, they have taken the open source Red Hat operating system and done things to it to maybe add features that are less conservative than Red Hat, would be Rocky Linux and Alma Linux. These are recent because CentOS, the previous downstream version, has now gone upstream. It's controlled by Red Hat. They decided to do that. Other people said, no, we liked it better downstream. So now you've got these new contenders. And then finally, there's SUSE, which has an enterprise version and an more open version too. At CAC, we mostly deal in the Red Hat and to some extent the Debian family, Ubuntu and Rocky at this point. So the problem with these is that the desktop experience is actually decoupled from the distro. So not only do you have these different distros that you have to figure out which one you want to use for whatever reason, but if you happen to, say, run it on a desktop machine or use a remote windowing kind of scheme to get a remote desktop, then that will not look the same for, say, Ubuntu. You have several desktop managers to choose from. They're all familiar in a sense. They will all have what is humorously referred to as the WIMP interface, windows, icons, menus, and pointers that you expect, but they'll be a little, placed in different areas or be called slightly different things. So you have to get used to that. And then maybe somebody else's Linux is going to have a different desktop manager they expect you to connect to. And you have to figure out the nuances of that. So there is not a standardized experience as you would have for Windows or Mac OS. They're not bad experiences. You just have to be ready to be a little flexible. In any case, access from the command line is more standardized. So that's really the indispensable way to get connected to a Linux operating system. There's a lot of power at the command line. And I don't know, for people out there, if you have a Mac OS or a Windows laptop, there are command lines for those too. It's called terminal in Mac. And in fact, for Mac, the terminal is BSD Unix. So a lot of the commands that I'm going to be talking about today are available in a terminal application in Mac. Windows, you can get the Windows subsystem for Linux, and that's, or WSL, that will be another way to get essentially Linux-like operation on within Windows. Okay, so that's some of the disadvantages, if you will, of Linux. It's not, just because it's free and open source doesn't mean it's flawless. Okay, so now let's get into the nuts and bolts of sort of Linux's view of the world. Everything consists of files and directories and processes. So a file would be a collection of data, and it's going to be in non-volatile storage, like a hard disk. So the location in the file system that sort of identifies where that file lives is called a path. path will be a series of words or directory names, really, but which are separated by forward slashes. Okay, that's pretty standard in Mac too. A directory is really just a special type of file. It holds information about other files. And you think of it like you would think of a folder in Windows, and it's a container for other files or directories, subdirectories. A process is an executing program. Okay, so these are the things that might do I/O input output to files. It requires some amount of CPU resource and also the typical volatile storage like RAM, that's active, fast memory that allows it to execute. So they can be short in duration. It might just print something and exit, or it may run indefinitely. System daemons, these things that manage system functions and have to run all the time. And these are all processes. They might be paused or halted, but they're part of what runs the whole show. Okay, so there's, if you then look at your collection of directories in Linux, you could think of it like a tree structure branching out from a trunk. If you have a full path with /directory/directory, that's the exact branch that locates a file or directory within this tree, starting from the trunk. So naturally, in Linux, the leading slash in the path, that signifies the trunk or root directory. So just slash by itself is a directory. And the main branches from there will have sort of traditional names that are common to most Unix and Linux systems. So executable files that are like part of the OS, they would be in /bin or /sys. And you might hear people refer to these things like, there's a lot of shorthand in Linux that you have to familiarize yourself with so that you catch on to what these things mean. /lib or /lib, some people would say, is a place where libraries live. 64-bit libraries came along and they were in a lib64 directory, but they're really the same kind of thing. It's system libraries of routines. And then /etc has miscellaneous input and output files for the operating system. Then you get into sort of the more user focused parts of the directory tree, and that would be /user. Linux tends and Unix tend to be very terse, and they left out the E from user, so it's just USR. And similarly, /temp is /tmp, and you just get used to it. Sometimes product software or large package will be in /opt. And home directories are often under /home, but not necessarily. Okay, so one thing I'm going to do today is to switch back and forth occasionally to a terminal window in Mac. And I told you that Mac OS, it has Unix underneath, so you can bring up terminal and you can see things that look a lot like Linux. Enough so that I'm just going to go ahead and we're going to play around in that world a little bit. So here's my Mac terminal. Ignore all this stuff there. I can do clear and just give ourselves a clean slate. So as I'll get to in a minute, I just wanted to preview this a little bit. There is a command to list files and directories in a certain directory, and it's the ls command for list. And I said that root was just /. So what happens if we list the contents of /? So that's what we get on Mac. And you see that Mac has the same kinds of directories I was referring to. So it's got a bin directory, it's got an etc directory, it's got apt. Some of these things are from software that I've installed and wouldn't necessarily be there. It's got a temp, it's got user, and so on. But the main, it's got these other Mac things grafted on, like users, which is under /users is under the root directory. So so what if I wanted to look at one of these? If I did ls/bin, then there's a bunch of things that are very Linux-like in there, commands that are a Unix kind of set of commands. And we would use them a lot like Linux. It's not Linux, but again, there's a commonality to this universe that, and in the case of Mac, it's actually since Mac OS 10, it's all Unix underneath. Mac OS is just a fancy desktop manager in a large sense. Okay, so that's the sort of the top level view of a Linux file system. So the thing you need to actually get your work done at the command line is a shell. So a shell is a particular kind of process. It's a command processor itself. So it takes in commands as a process and it runs them to make different things happen within the operating system. So various shells are available for Linux and Unix. They have their pros and cons. And again, like in the Linux world, there's not one solution here. They all have slightly different syntax, but there's a commonality enough that they, especially between Bash and on the one hand and TCSH on the other one, descendants and relatives are all going to work pretty much the same, with some improvements often. So Bash, it started out as a shell called SH. Bash actually means born again shell. It's a pun. And TCSH is a C shell. It has C-like syntax in some ways. There are other options. ZSH is sort of a Bash derivative, and now that's the default in newer Mac OSs. But in most Linux distributions, you'll find that Bash is the default shell, and so I'm really emphasizing Bash for this presentation. Okay, so I already hinted about how you work with directories. That is, you can list the contents of a directory there. The second bullet is ls. If you want to know where you are in the directory tree, you can print the working directory, and it will specifically print the full path to the current working directory. CD is how you change your current directory. There are common abbreviations. So one is the tilde character. In terms of directories, that means your home directory. You can put that within paths typically to have it, you don't have to type out the full path to your home directory. You can just start with tilde and then go from directories under that. If you were to do cd dot dot, the dot dot means one level up in the directory tree, one level closer to the trunk. And if you wanted to make a new directory with some name, you do that with mkdir. Again, it's this sort of shorthand that Linux has, that's the command make a directory. So just to illustrate that quickly, if I'm here in my home directory, I might want to know, well, where is that? So on a Mac, it would be /users/slans. But if I were on a Linux system, that might be under /home, say. And then if I do ls with no arguments, it will list the current directory. So that's what I have in my current root directory. And on a Mac, it's got certain special, the capital letter directories are the things that are Mac-like. Other things are just files and directories I've created over time. I could do an mkdir new directory, and that would be a new directory. I could cd into it and say, what is my current directory? There it is. Okay, so that's sort of a quickie tour of the ways you navigate around in the file system from the command line. Keyboard shortcuts. There are handy things to know that I'm going to cover sort of early on here because they're so useful. It saves typing, basically. So you can use the up and down arrows to retrieve previous commands. And I'll show all these in a moment, but just to preview here. Left and right arrows will move the cursor within a line for editing. You can use the tab key to autocomplete a file or directory name. Very handy. And the exclamation point character in Linux speak is referred to as bang. So bang bang repeats the previous command. It just does it right over again. Bang dollar is an abbreviation for the final word or string in the previous command, so you don't have to type it over. You can do bang NNN for some number that will repeat the command number. And then if you wanted say the last make dir command, you would do bang M, and that repeats the last command beginning with M. So lots of fun little shortcuts there involving bang. If some of these involve the history of the commands you've been entering lately, so if you want to display a list of them, you do history with a number, and that, or it will, if you do it without a number, all the ones that remember will appear on standard out. So, and I'll talk about what I meant by that. Just to quickly show some of those. So I do up arrow, and there's my last command, the command before that, the command before that. Okay, so now let's say I wanted to make a new directory inside this directory. So I'm going to call it new dir2. And you see all I had to do was that. Or I could call it another new dir. And so I would do that by editing that command. And there we go. So if I do ls now, there's my, and if I do the working directory, you see I'm in there. I can cd into AN and now do tab complete, hit tab, boom, there's the rest of that directory name. And now if I print the working directory there, I'm inside my second directory. Okay. All right. So that's, oh, I didn't show history. I wanted to do that. So if I just do history, say 10, there's my last 10 commands. And if I wanted to repeat command 554, then that's the pwd command, so there's that. And yeah, good. All right, so now there are ways to, other tools for working with files and directory that are standard to use in Linux. The copy command is CP. There's a move command, which also you can think of as a rename, and depending on context, that moves, say, file 1 to, or renames it to file 2. So just to show that you have to think about what these are actually doing. So in this case, we copy file 1 onto file 2, and you know, we can also do a move. And they would have different effects. If file 2 existed, in this case, file 2 it would complain. You get an error. If you moved file 1 to file 2, it would just overwrite it, and that's, you got to be careful. And then also you have to think about file name versus directory name. So if you do cp file 1 to directory 1, that actually copies the file into the named directory. If you move file 1 to directory 1, then it really doesn't move. It moves the file into the directory. If you do move directory 1, directory 2, two directory names, then if directory 2 is not an existing name, it will rename directory 1 to, or dir1 to dir2. If, though, say dir1 is the existing directory and you had some dir2 and you did the move, then you would bake dir2 into a subdirectory of dir1. So I'm not trying to confuse you. It's just that this is whether the file exists or not matters in how the commands behave, and whether it's a directory or not influences how the command behaves. Okay, then there is a rm command for remove or to immediately delete a file. It does not work on directories. For that, directory, you have to remove the directory with rmdir command. And it should be empty. So you have to remove everything in it. There are ways you can do that recursively. I'm not going to get into that right now. Something handy you can do, let's say you had a bunch of C source files in the C language, which are in Linux typically ending with .c. So then the wildcard matches anything that's a string that is before the .c. So all the source files ending with .c would then be moved into one level up directory, codedir, okay? So that is just an example of how wildcards can be used to bulk move, remove, do things with files. And it's probably one of the most useful shorthands for doing stuff like this. So just to illustrate some of these, if I'm in my another new dir here now, I can touch a file. And that touch is a command that it moves the current timestamp on the file up to now. But if the file doesn't exist, it just creates the file as a file that was created now. So now I can do ls, and there's my file one. So I do mv file one, file two. Okay, and now I'll do ls, and there's just a file two. So now what happens if I do touch file three, and I do mv file two? Okay, let me do ls first. So I have two files. I do mv file two, file three. And now I've just got a file three. So whatever was there for as file three has been written over. But I can maybe restore that by doing a CP to get it. Well, now file two will be a copy of file three, but there's nothing in either of these. Okay. So you see how this kind of stuff works. Now, if I wanted to make a directory one level up, I could do something like this. Then I can move file star. So the star will match file two and file three. And I want to move it to this new file dir. Okay, then I can ls./file dir. Actually, I can do tab complete, right? Oops, yeah. And there's my files one level up in this new directory. Okay, so that's how that all works. All right. So if you wanted to look at what's in a file, you can do the cat command. Cat is a shorthand for concatenate to the terminal. Some of these I think were named somewhat humorously, cat being one of them. If you want to just see the beginning or end of a file, use the head or the tail command. Files can be very long, and you don't want hundreds of lines of output just spilling onto your terminal. So there's a handy command called less. Less just gives you one page at a time. That is, it lets you advance a screenful by screenful instead of just having to scroll back or something to see all the output. And also, if you wanted to skip to a particular line that you knew it had something that you wanted to see, then you could use you type search, type a slash to search within the file for that string. A much more powerful version of that is grep, which prints lines that match a specified pattern out of a file. It doesn't print the rest of the file at all. I'll illustrate this next with just in my terminal window. So let's go ahead and do that. So I'll do cd to my home directory again. And if I do ls in there, we see that I have a file called states50, and also one called states. So I might want to see what's in those files. So I can do cat states. And it appears to be a list of states. Okay. And then I can also look at a particular state in that list by doing grep. Let's say I wanted to get all the states to begin with O, so I do capital O in states. So I get the two states that have the capital O in them. This file is not long enough actually to need less. So what else do I have that we could look at? I wonder if that Python program there. So if I do less pi mpi.py, then you can see this is a Python program, and I've gotten the first screenful. If I want to see the next screenful of the program, I hit the space bar, there's some more, and that's the end of it. So to get out, I type Q, and then let's say that I wanted to, I knew the value of pi was in there, so I do grep, did I call it capital PI? I'm not sure. Just tab complete there. Okay, maybe I called it just lowercase pi, but I could use an option to grep to actually make it ignore the case. Yeah, and there we got the pi to 24. Well, I guess I had it before too. 25 places right there, which I wanted to see from within the program. I could just grep for it instead of, or I could do less. And then do, I want to go to the line with starting with pi. So there it goes, and it shows, it highlights the occurrences of pi, and it'll skip to the next one. By hitting N, I can go down to the line I wanted to see. Okay, so handy ways to get around in files. Okay, any questions at this point? I've been going briskly for about a half an hour, so if there's something you saw that piqued your curiosity and you didn't get a chance to ask, you can do so now.
There's one question that just came in. It says,
Okay.
Now that Mac terminal defaults to ZSH, what are some common pitfalls considerations when working in terminal if you are used to bash?
Good question. I have actually not worked in ZSH. I did help a graduate student who wanted to customize his ZSH environment, and I found that there were some differences from bash, but they were subtle. One being that if you wanted to, say, set the custom settings, there is a specific file that I'll talk about later that has a different name in ZSH. It would be the bash. There's a .bashrc file. Again, this is something I get to later. In Z shell, I think it's called .zshrc. So different little things like that. And there are new capabilities in ZSH I haven't explored. So it's more added on interesting features than is anything incompatible. Okay, thanks. Before we leave grep, I wanted to point out there are other options. So there's -r, which searches a directory tree recursively. And there's a -v option, which means to invert the search. That is to say, you want to find the lines that don't match a certain pattern rather than match it. All these are really nice for finding all occurrences of something in a directory that you know which, it's in some file, you forget which file, and you can do grep and find it. Okay, so I've been talking about options without really introducing them. So let me give a little more thorough coverage there. So options, also referred to as flags, begin with a dash. These are there to modify the action of the command in some way, and examples from grep I was just talking about. So in Linux command line, they're usually specified in one of two forms: a single dash, followed with a single letter, and then an argument if any, after a space. So there's an example of the head command showing that would print the first 10 lines of the file. But there's an equivalent way to do it with the other form of the Linux option, which is a double dash followed by some longer word, not a single letter, equals argument if there's an argument. So that second command there is exactly the same effect as the first. It's just a different way of expressing it. And it certainly is clear what you're trying to do there, I think, compared to the -n. You have to memorize what all these things are. Now, any of these common Linux commands come with about, I don't know, anywhere from 10 to 60 flags. And there's often when you're working with command, you can't remember which single letter it is that you need to do something. So if you need a manual page on a certain command, that is the information about it, you would go to man command name, and then you would get a catalog of all the options that exist for that command. So again, to look at this on the terminal, if we did a head 10, a -n10, and then we did this file I've been using, and I'm going to use the shortcut here, which is bang dollar. Okay, that's the last word, remember, from the previous line or the last string. So that gives me the first 10 lines of my program. But I could well have done that by using the less equals kind of way of doing it, or lines equal. And that's this. So I use the up arrow, then I can left arrow to get over here. I can do this. And same answer, different option. Okay. Oh, and I wanted to do the man page for head. So if you can't remember what options are available, here's how to do it. And you can see that I could have, instead of specifying a number of lines, I could have asked for a number of bytes, where a byte would correspond to, say, a character. So just interesting, you know, maybe that is useful sometime. Okay. So back to the slides. Permissions. Just like in any operating system, who can see your files depends on the permissions that are set on it. And the way to know what the permissions are to use the ls command with the -l flag or option. That means long format information. So I'm going to illustrate this in a minute, but it includes the permissions as well as a lot of other things pertaining to the file, much more than just the file names you saw with ls by itself. There are the main command for changing permissions on a file is chmod. It has a really obscure kind of syntax. Not too bad once you get used to it. But two things you might want to do with chmod are to make it so you can execute the file. So if you wrote a script and you want to execute the script like it's a command, you can chmod it, change the file mode to +x. So this does u, that's you as user, or maybe just you, the current user, is now able to execute file 1 after that command is run. Then chmod, and here's the other way you can do it, is a set of 3 digits. And these are digits 0 through 8. Or sorry, 0 through 7, right? Because it's setting bits, basically. You have user, so there's the 600, it's really a binary encoding. The 6 is this first group. Oops. 110 is just, 4 plus 2 plus 0 is 6, so that's the 6. And then zeros for the rest. These first 3 bits are the user bits. The next 3 bits are the group bits. That is people who are in your same group. And the final 3 are everybody. And so this is a way to make it so that only you can read and write a certain file. Nobody else can see it. So those are some common things to do with chmod. I just not going to illustrate that so much as just to go in and show the output of ls-l. and I'm in my home directory now, so I have lots of files in there. And you can see that I have some are read and write by me, read for other people. Ds are prefaced with, means it's a directory. And this one is, it has to be executable for people to actually list it. I have a script here called swappy, which is executable. And so that's how to parse the output there. Here's me as the owner. Here's my group. It has now the date is here for me to see. If it's a recent time, it will actually not give the year. Instead, it will give the last modification time. This is the size of the file in bytes here, and so on. So it gives you much more insight into your files. Okay. All right. The commands that we've been running have written output just to the terminal. And it's not necessary that it works that way. You can, what it's really writing to is called standard output. Standard output is, by convention, is the terminal, but you can redirect it. And there are certain ways to do that in command line syntax in Linux. So let's say that I want to take that list of files that I just showed you and save it in a file. I would then redirect the output like that, using the greater than sign. And instead of showing up on the terminal, it would show up in this file. I could then view the file, edit it, whatever I wanted to do. If I wanted to list the contents of directory in long format and then append it to a given file, that's two greater thans right next to each other. It won't redirect just with that error messages. So there might be an error message like you don't have permission to view this file or something. That would actually go to a different stream called standard error, or STD error, you'll see it referred to. That also can be redirected. It can be redirected to a different file. So that's the numeral 2 followed by the greater than sign will show where to redirect standard error. You can redirect both streams to the same file. And that shows how to join the standard error to standard out there. Funny syntax with the ampersand. There's a special file called /dev/null. And that is the bit bucket. That just says that's nowhere. Anything you send to dev null disappears. So if you don't want to see the output from a command you run, then you redirect the output to dev null, and you can send the standard error there too if you want. Okay. So likewise, there's a standard input to commands. We've been typing them at the keyboard when we run commands. But if there were input you wanted to take from a file instead after the command was running, then you can redirect it with the less than sign. And that's denotes how to get input in. I'm not going to go into detail on these, so just so you're aware of what that syntax means. Okay, there is a really kind of cute way to combine standard out and standard error that lets you chain commands together in Linux and Unix. So this chain is a pipe. It's denoted with a vertical bar. It takes the standard out from the first command and it feeds it as a standard in into the second. So let's say that you wanted to get output from your some command and it's a lot, and you know it's going to be a lot. If you pipe it through less, then that means you will get a page at a time. You can advance through it by the spacebar and do that search trick that I showed with the slash and then a string. All that stuff works on the output of a command when you use the pipe. You can take the output of a command and use grep and find just one particular string in that output. You don't want to see everything. You just want to see a particular the results for a particular pattern that is within that command's output. So you could grep for something in your history. And that's a common use case. Another one might be you just want to see, like, you don't want to see all the files in your directory. And you could do something like ls-l. I want to see all the files that have the string 50 in them, and I could pipe that to grep 50. Okay. And in fact, I have this states 50 file, and that's if I cat that, you see this a list of the 50 states. And I guess that states file didn't have all of them before, because this actually went beyond the screenful. So I can pipe that through less. And now it gives me just the first screenful starting with Alabama, and it goes all the way down to Wyoming after I hit the space bar. Okay. Other ways you can use pipes is for sorting and counting. So you can sort all the lines of your output. It'll be alphabetical by default. And you can change the ordering by different options. The man page will tell you. You can count the words or lines of output. And it will then print the result of the count to standard out. You won't see all the lines themselves, you'll just see how many there were. You can grep for a pattern, count those lines, because you can chain these pipes together, or thread them together. I don't know, something pipe-like, so that you can continue any number of pipes, and it will just keep feeding the standard out of the one to the next one, standard in. So let's try some of these on our states 50 file. So if I do that and now do sort won't do much because they're already alphabetized. So what if I do sort -r? Okay, so -r means sort in reverse order. So now it's in reverse alphabetical order. And it's like, oops, I got too many states, so I'm going to pipe it through less again. And you see it starts with Wyoming now and goes through to Alabama. Okay. And maybe I want to make sure there's really 50 states in there, so I can do WC-L, and there's 50. The states file, if I do states, cat states, oops, that's not, yeah, that's good. Okay, so you see that I had Guam in there, so somehow I managed to get Guam out of there, and and I can actually make sure that Guam isn't in there by doing grep Guam states 50. Okay. All right. Moving along here, let's see, where are we? We're in 9 minutes to go. We still have 5 slides. We could make it here. Environment variables. ENV will print all your environment variables. What are those? So these are variables that are available to any command that's executed in the current shell. And they're also inherited by child shells. So if you execute a script within your shell, the environment variables will be available to the script as well. I didn't talk about this yet, but bash commands, you can put them into a file. And if you execute that file, it will run the commands in a subshell. And it's just like a program. So you're writing a bash program in a sense, interpreted program. Just as if you're typing it, but in a subshell. The way you add a new environment variable is to do export. So in this case, we have the variable var, and we set it to the string val. And then what sends it or sets it up as an environment variable is this export command. Otherwise, it would just be a local variable. It would not be available to subshells or shells that are like the script that you're running in your shell. Okay, echo will tell you the variable, in this case, var's value. Um, and I'll illustrate that in a second. Um, so then there's a particularly important environment variable called path. Um, path is the list of directories to search for commands. That is to say, you might have multiple commands called ls. Well, I'm not sure that's a good example, but let's just, for the sake of argument, say that's which one? Where does it find it? And the answer is it uses the path. And as it goes through the list of directories in the path, the first one that comes to it has an ls. That's the one it uses, which will then identify how the result of such a search in path. So let's go ahead and just look at some of these things. So I'm going to first do end, and that shows that I have many of these environment variables set. That's typical in the operating system. You just different applications that are running in even the OS, that they're going to set environment variables. So path is there. I can just look at it alone by doing echo $path. So there it is. And if I wanted to do which cat, I'm not sure if this is actually about, yeah, there you go. So it found it in /bin. So if you look at my path, if you go down, there's some special directories, and then it gets into these very Linuxy-like directories, local bin, user bin, /bin, there it was. So that's the first place it found the cat. So that's the one it's using. So if I had something called cat that was an executable in one of these other directories, like in condabin, okay, that would actually take precedence. And you have to be careful about that because maybe you don't want that cat. Maybe it works a little different.
Which Python, Steve?
Which Python? That's a great question. I don't have a Python. However, I do have a Python 3. Okay. That's one that I installed myself, I think. Or it might have come with the OS. I'm not actually sure. Yeah, so that's a good example, Ben, of something you might want to, and a common gotcha is you're using some Python you weren't expecting. It might be Python 2 to just type Python. Okay. All right. So there are more files than you see at first because of the fact that you can hide a file from the ls command, at least the usual invocation with just ls, by preceding it with a dot. So these are usually special files and directories. They often have some special role within the operating system, within your environment. Some of these dot files and directories, which you find in $home. $home is the same thing as tilde, by the way. And they're worth knowing about. So there's a file of commands that get run when you log in. That's called the dot profile in your home directory. There's a file of commands to run when you start a non-login bash shell. It's called .bashrc usually. These have different names in Mac OS. Okay, so and in different shells they would be called something a little different. But just so you're aware that this is, you can affect your environment. You put in your .bashrc, I want to always set this environment value to this variable, and you can do that in the -rc, and then it's always there for you like that. There's a special directories that can start with dot. Excuse me. For SSH related files, I'll talk about that more in a moment. There is a directory to store those things called .ssh. Right, at this point, I'm going to step out again to the terminal, and we're going to take a look at some of these things. First thing I'm going to do is an ls-a, but that's not going to be real satisfactory because there's so many things. You see, I have lots of dot files there. And I want to really just focus on the ones that begin with dot. Okay, well, maybe this will do for now. I'm going to go ahead and just show you what's in the .bash underscore profile, which is the Mac OS equivalent. I can do cat. And you see that I have a certain environment variable that I want to set here. So certainly I'm not going to want to type that by hand. So that just gets stuck in my or in this case, .bash underscore profile. Other different little things that I just find handy, I stick in here. And this gets run by on pretty much every terminal window. Of course, there's danger to that too, because now you've affected your environment for everything that gets run. So you have to be aware of what is in there if something is, especially if something's behaving unexpectedly. Okay. And then we want to talk some about SSH. Where are we now? We're almost at the hour. SSH is a subject all in its own right that I couldn't possibly cover in this 1 hour overview of Linux. But when you're using research computing servers or cloud instances, you often connect to them with SSH. You're using a key pair type of login to authenticate. And this .ssh directory contains the things you need to do that. Your public key for where your destination is must reside in the authorized keys file in .ssh. On your local computer, you usually have your private key. So on my laptop, I would have this ID RSA, and that allows me to authenticate automatically if I have it set up correctly. So let me just illustrate that real fast. First, I can do ls.ssh. So there's the things that I'm talking about. I don't have any authorized keys file here. Nothing can remotely log into my Mac with SSH. But I have the private key right there. The default private key is ID RSA. So if I do SSH to a particular machine here at CAC, it has my matching public key there. So in the, I'll just go ahead and do that. My config says that what my username is on Linux login, so I didn't have to type that. And then if I do ls.ssh here, you see there is an authorized keys file, and that has my public key that matches the ID RSA on my Mac. That's how I was able to log in without a password. So that's a real quick overview of SSH. And you see I'm on a bash command line. I have the same kind of commands available to me on Linux login that I did from the Mac terminal, but actual real Linux commands now. Yeah, so that's a very much too quick overview of SSH and its role in Linux. And then there are a whole list of things that we're not going to have time to cover. You'll often want to work with a text editor, so you can change your files as needed, other contents. The most common or popular ones are Vim, which is the most modern form of VI, visual editor. Emacs, it's practically a shell in its own right. I mean, it's very powerful as an editor. Nano, which is a very simple editor that you don't have to really learn. Emacs, and even VI, take some specialized sort of like focused attention to master. I talked about SSH. If you need to see, am I using up all my disk space? There are a couple commands there for that. What's using my CPU? That is answered by the top command. There are options to top that help you view it in different ways. You can also see how much memory things are using with top. You look at the man page for all of these. There are tutorials you can find online. Emacs has its own built-in tutorial. All very useful things to know. Not going to have time to cover them, but I thought they would be worth mentioning. So further learning you can do by going to the Cornell Virtual Workshop, which we at CEC put together. Many topics in research computing can be found there. We have one specifically on Linux that I drew from for this presentation. Similarly, we have for our Red Cloud users, there's a Linux tutorial that at that link that focuses more on elementary system administration stuff, because when you have a cloud instance, you can be the root user, root in this case meaning the user that's authorized to do everything. You can install things, you can do whatever. So that concludes the presentation, and happy to take further questions at this point.